Hello, good morning. In this video lecture, I will tell you about some basic concept of the laser and the properties. Then after the three basic the process which we use in laser, which is required actually to explain that. So let me explain it one by one. First of all, laser. Laser stands for, as you know, that for light amplification by stimulated emission of radiation. And here when we say that light amplification, this we treat is in the same sense as we amplify the sound. So how one can amplify the light, this is the important point. And what is that process? That process we use stimulated emission and we amplify the radiation. So here the main important process is stimulated emission. This is process which we use, right? So laser stands for light amplification by stimulated emission of radiation. Laser is a very intense, concentrated, highly parallel and monochromatic beam of light. Coherence is very important property of laser. And when we use this word coherence and incoherence, what is it means basically? Incoherent means the light emitted from the sun or other ordinary light source such as tungsten filament, neon and fluorescent tube light is spread over a wide range of frequency that basically is in visible spectrum. So 7 colors remains there. So a normal bulb and sunlight is an example of the incoherent light. For an example, sunlight is spread over infrared, visible light and ultraviolet spectrum. So the amount of energy available at a particular frequency is very less and hence less intense. Such light is irregular and mixed of different frequencies, direction and duration, and is incoherent. Incoherent light is due to spontaneous and random emission of photons by the atoms in excited state. These photons will not be in phase with each other. So this is just an example of the incoherent light. Here you see the random emission of the photons in all possible directions. So this is an example of incoherent light. And now there are some questions. Questions are: what are the possible radiative transitions? What is the probability of transition taking place? How does the number of photons change with the transition? These are some basic questions which can arise in your mind also when the ground state to the excited state electron jumps, or from excited state to the ground state. Now the point is about coherent light. Coherent light is uniform in frequency, amplitude, continuity and constant initial phase difference. So here the most important point which you have observed, that is the constant phase difference, right? Here phase difference remain constant in all the waves or all the emitted emission. So coherent beam of light is obtained due to stimulated emission of photons from the atoms jumping from the metastable state to the lower energy state. So this is an example of coherent light, and here you can observe that all the waves are in same phase, so there is no variation into the phase. Frequency is constant, right? Amplitude and everything unidirectional. So this is the property of coherent light. Now this second and important concept is about the process. So how many process basically runs in the laser process? So these are basically three, and one is induced absorption, second is of emission. And emission are of two types. One is spontaneous emission, second is stimulated emission. So let us see this induced absorption. Here in this case photons of suitable size, energy suitable photon of suitable size, it means that the particular energy h nu are supplied to the atoms in the ground state. These atoms absorb the supplied energy and go to the excited state or high energy state. If EI and EJ are the energy of ground state, these are correspond to the lower energy state and excited state, higher energy. Then the frequency of required photon for absorption is nu, and nu is equal to EJ minus EI upon H, where H is a Planck constant. Right, so by picture you can see like this. Here atom is into the ground state, that is correspond to E naught, or as I have written earlier EI, and EJ is the higher state. So this atom absorbs the energy and goes into the excited state by this way. Right. So this is the process of absorption, and next is spontaneous emission. What is spontaneous emission? What do you think about it? An excited atom can stay in the higher energy state only for the 10 raised power minus 8 second time. After this time, what happens? It returns back to the lower energy state by emitting a photon of energy E1 minus E naught. So I can write here H nu is equal to E J minus EI, or if you are using E2 and E1, then higher state to the lower state, and this emission is called spontaneous emission. Right, during spontaneous emission, photons are emitted in random direction, and hence they will not be in phase with each other. Therefore, the beam of light emitted is incoherent. Right, this is the case. You can see here, atom is in excited state. This is AJ, EI, or E2, E1, it does not matter. So now atom after 10 raised power minus 8 seconds, right, it emits a photon in random direction, and as a result you get the incoherent light from the spontaneous emission. Here one question may arise in your mind: what is the difference between absorption and stimulated emission? Do these three processes run simultaneously in the case of laser? When you observe the laser light, the question arises at that time: does these three processes run simultaneously? Yes. But before that, I have to explain one thing here, that is the ground state. And here, with the help of this picture, you can see that all these three friends are watching TV, enjoying these snacks, and sleeping. And so this situation, and now observe this situation. They observe something different, and as a result, their internal configuration has been changed. So now they are in excited state. You know these two things. So how you basically can explain the ground state of the atom and the excited state of the atom? So in the same way, if I have to explain ground state and excited state, these basically are associated with the electronic configuration. In the excited state, what happens? Atoms electronic configuration change. So for an example, if you are using neon or helium or anything, right? So neon is 10, that is 1s2, 2s2, 2p6. So 1s2 electron or 2s2 electron or any other electron basically jumps from this state to the other state. For an example, 1s2, 2s2, 2p5, and it goes into the 3d1 like this. So now electronic configuration has been changed. So this was the ground state, and this is excited state. So by this way one can explain here. And now the third process, that is the stimulated emission process. Here what is the important point? Point is when photon of suitable frequency or energy is showered on an excited atom in the higher energy state, the atom falls back to the ground state by emitting a photon of energy h nu. E1 minus E0, higher energy state to the lower, which is in phase with the stimulating photon. So by which appear one additional photon. This process is known as stimulating emission. So here you can see that atom is already in excited state, that is E1 here. You can write E2, E1 or EJ and EI. It does not matter, as I have already told you. So before emission, this is the situation, and here you can see this external source of the energy, and as a result, now what happens? This excited atom jumps into the ground state and emits these two photons. So now these photons have the same frequency and in same phase. So obviously they will move in the same direction, and this is known as coherent light. So in a laser, you know that we require coherent source. So if the information is helpful, so like and share the video, and you can ask the question in the comment box.